Divergent. Very good, okay. So I will use that vocabulary in this lesson. Are we recording? Yes, we are. And we're saving, and we're good. Okay. Right, let's have a look at a series here. So suppose I had something like this, Fn is, everything for the exam has been done now. So this is new. No, not for you. Do you want to? Oh yeah, do you want to go actually? Yeah, this I'm doing page 42. You haven't seen this? Yeah. You have seen it? Yeah.
This is no exam.
Yes.
Is it our exam?
Because I haven't written your exam. No, hang on. First, relax. Your exam has been written by Joan last week, so it's not going to change. Okay, it's everything up to the lesson you saw today. Not including this. Not this one. So, this next lesson is not on the test. I will say that 3 more times because people will ask me 3 more times. So I'm going to say it now in one go, alright? This next lesson is not on the test. Teacher, is this lesson on the test? No, this one's not on the test. What about this lesson? Could it be on the test tomorrow? No. This next lesson is not on the test. You got that? Yeah. So I'm not going to say it again. It's everything up to the last lesson. Yes? Do you want to go actually, because you've seen this one, or do you want to see it again? Which is it? Stay or go? See it again? Yep. Second, do you want to stay and see this lesson again on page 42, or do you want to go? You'll stay? Why not? Alright. Can you do this one for me? I have 1 plus 2, just a sec. It's 1 plus 2 plus 4. It's a sequence like this. 1 plus 2 plus 4 plus 8. I want you to calculate the first 10 and the first 100 and then the first 1,000 terms added together. Yeah, so A is 1, OR is, what's OR? 2, and the N is 10, 100 and 1,000. Hope. Is that right for the first one? Yeah, but still I wanted you to try it. No, it's not that. What is it?
It's 1023.
The first one is
1023.
1023. And what about the... Oh, sorry, I was doing the next one, wasn't I? This was 2040... No.
No, not
1023. Okay, what about this one?
1.26 power into
1.26?
7 into 10.
Power 30. And this one is actually too large for the calculator to do. So this series is divergent. The more you add, the bigger it gets. Yep. Okay, try this one for me. I want you to do the same. I want S10, S100 and S1000. Do we have maths tomorrow?
Yeah,
No, maybe not.
maybe.
I don't know. I know the science and business guys do. But maybe we can not do the engineering one.
Okay.
Maybe. Too generous. It's my one weakness. Okay, you got those three? Yeah. What's the first one? S10. Do we have an answer for S10? Not yet.
The formula is the same of now.
Oh yeah, A 1 minus or N over 1 minus or, yeah.
A minus.
You know the formula. A 1 minus or N over 1 minus or. You know, it's the one I used in the last lesson. Okay, what's S10 here? Do we have an answer? I want it as a decimal, please. 1.99. Okay, so it continues like this. Yeah. S100? Basically, the calculator is going to round it off to 2.00 exactly, and 1,000 will also become 2 as well, 2.000, etc. So this this series is not going to infinity. What's happening here? It's moving towards 2. So we don't say it's divergent, instead we say it's convergent. So what is the difference between the first example and the second example? Why does the second example converge but the first example diverge? That is, what is making the second one converge and the first one diverge? 2, yeah, but why? I mean, what's the key difference between them? I mean, why is it going, yeah?
The ratio is less than 2.
That's exactly it. If you look here, what's the OR? It's 2. When you multiply a number by 2, it gets bigger. And when you add them all together, it's going to be very big. But here, what's the OR? It's a half. When you multiply by a half, it gets smaller. And when you add them all together, it's still not too big. It's quite small. So in fact, that gives us our first result, that if the OR is between -1 and 1, it will be convergent. If the OR is bigger than 1, or if the OR is less than -1, it is divergent. Okay? Yeah? So we have another formula to look at. I need to scroll down. You got that result? Yes? Yep. So you know the formula for Sn is A plus AOR plus AOR squared, etc. What about S infinity? There's no difference. It just continues forever. It keeps going. There's no stop here. The formula you think might be the same, and it nearly is. This would be 1 minus OR power infinity over 1 minus OR. But you might be thinking, what the heck is this? Alright, OR power infinity. Does that even mean anything? Well, it does, but only if the OR is between -1 and 1. So if you were to look at your calculator, just at the side for the moment, type in 0.5 power 10. Is it large or is it small? Small, isn't it?
Yeah.
And what about power 100?
Even smaller.
Yeah, and go for power 1,000,000.
1,000 gave you 0.
1,000 gave you 0, yeah? So 1,000,000 is pretty close to infinity. When you have a small number, less than 1, to the power of a large number, the answer will be small. In fact, when you have a number less than 1 to the power of infinity, the answer is so small that it becomes 0. So this gives you actually your formula. If you want to calculate the sum of all the terms, it's just A over 1 minus OR. This piece is gone now. But remember, this only works if or is between -1 and 1. Otherwise, there is no answer because it's divergent. Let's do the first question in the book as an example of this formula. So I have here 3 minus 3 over 2 plus 3 over 4, etc. Question? Hey guys, if you have a question you can ask. Is there a question? No? Oh, okay, it's my handwriting. That's fine to ask as well, you know. It's okay. Right, let's look at this one for example. So first we want to check if it's convergent or divergent. Or equals minus 3 over 2 over 3, which equals minus a half. So convergent or divergent? Convergent. So because it's convergent, it will have a limit. Let's calculate the limit. Using my formula, it will be A over 1 minus or. That's 3 over 2, which is 2. Is that right? Yeah, 2. Okay, did you write that down? In the exam, the final exam that is, they sometimes ask students to say if it's convergent or divergent. And the question is only 1 mark because all they want you to say, literally 1 sentence. You say, the sequence is convergent because the OR is less than 1. It's between minus 1 and 1. So in the exam, you would say something like, the OR is between minus 1 and 1, so therefore it is convergent. That's all you have to say. And it's only 1 mark in the exam anyways. So it is important. It could be in the exam. Okay, so what I'm saying here with this question is, if you add every single number up, the total should be 2. That's what I'm saying here. So you definitely shouldn't believe me. Let's have a look and see that for ourselves. Okay, what's the first term? It's 3. And the next one, it's minus 3 over 2, which is minus 1.5, isn't it? Yeah?
Yes.
And then the next one is, what is the next one? 0.75. Okay, and then the next one, and the next one, and the next one. So let's go all the way down to, let's say, 100. So if I add the first 100 terms together, let's see what we get. 2. Which is not surprising, okay? Now it's not, to be honest, it's not quite 2 here, it's slightly less than 2. But the Excel program is rounding up. Okay, but you can see that it is 2. Okay. What's the name of this type of sequence? What are these types of sequences called? What are these types called? Oh, nobody remembers the name? This type of sequence? No? Recursive. Do you remember this recursive sequence? You're looking at me like you don't remember. Do you remember these sequences or not?
No.
You don't remember? No? Does anyone remember? Yeah? You did it like a week ago? Yeah. So let me remind you. If I tell you the first term is 2, the second term would be 4 minus 3 over 2. Does this look familiar? No? What's 4 minus 3 over 2? 5 over 2, is it?
Yeah.
the next term, T3, will be 4 minus 3 over 5 over 2, which is 4 minus 6/5, which is 20/5 minus 6/5, isn't it? 14/5? I don't know. What's the answer here? Is it 14 over 5? People with calculator, person without calculator, please tell me what this is. What is it? It is 14 over 5. Okay. Give me T4 would be 4 minus 3 over 14 over 5. 4 minus 15 over 4. 56 minus 15. 41 over 14. Okay. So I want everybody now to calculate the fifth term in this sequence. Here's the formula. And I tell you to start at 2.
1 to 2 over 4.
1, 2, 2 over 41. Yeah. Now can we just make all of these decimals, please? So this one here is obviously 2. This one here is 2.5. What's this one? 2.4. What's this? 2.
That's 2.8.
This one's 2.8? Oh, sorry, this is 2.8? Okay, what's this one?
I know the last one is 2.975.
This last one? Okay, 2.975.
75.
And this one here? 2.92. What else? Right, is this sequence going to infinity?
No.
No, so we don't think it's divergent. What do we think it is? We think it's convergent, and in fact we think it's moving to 3. What?
No,
No? Convergent? Convergent. Convergent. Oh, what is this type called? Recursive. Yeah? I'm not sure what the question is. You did do this? Yeah, I know that. The problem is you don't know that. Right, so this sequence here, we think it is convergent, and not only that, we think it's approaching 3 as the limit. Although we can't be certain, maybe it's actually approaching 2.95. We don't know exactly what the limit is, but we think the limit should be somewhere near 3. So let's try and calculate it. What was the first term? What was the first term? No, 2, wasn't it? No, don't talk, please. No, I just need you listening, that's all. So what was the next term? 4 minus 3 over 2, which was, what did I say it was? 2.5, was it? 2.5, was it? 2.5. What was the next term? It was something like 2.9, wasn't it? Or 2.8. And then so on. Let's continue this sequence up to term 100. So do you see what's happening here? As we go further along in the sequence, it's getting closer and closer until it reaches 3. So we can see that 3 is the limit here. But of course you can't do this in the exam. You don't have Excel. So we need a way to calculate this. So let me show you how you can calculate the limit. So how can we get the limit here? So before I show you the method, I want you to notice something. As we get closer and closer to the limit, the neighbours get nearer and nearer. For example, at the beginning, the difference between the first and the second term was 0.5. Later, the difference is like, 0.1. When I go very far along, the difference here is very small, isn't it? And in fact, if I go far enough, the difference is gone. There's no more difference between the terms. So, if n is large, I think Tn and its neighbour, Tn minus 1, they should be roughly the same number. I'm going to call this number x. So I think x is 4 minus 3 over x. Now let me just go back here. Look, if I go down here, if you type in on your calculator the formula for the next term, it is equals 4 minus 3 over 3. What does that equal?
3.
It equals 3. Yeah, and again, just look here. If I look at this over here, 3 equals 4 minus 3 over 3. Is that true? Yeah. So what you're trying to do, when you make these the same and equal to x and change this into this, you're trying to find what number will have its neighbour as the same, and we think that this is the limit. So what number will have its neighbour as the same number? That's what you're trying to do here. In other words, replace this and this with x, and you make this equation. Let's try and solve this. What should I do to solve this? What can I do to simplify it? Yeah, I should multiply by x. So I get x squared equals 4x minus 3. X squared minus 4x plus 3. Oh, this is our friend the quadratic, which we can easily solve, yes? Too much ease. X minus 3, x minus 1. So x equals 1 or minus 3. Now there can only be one answer, not two. Which answer do you pick? Which do you think is the right answer? 3. And which do you think this one is the wrong answer? The only way you can know that the answer is 3 is if you calculate some of the terms and then decide which one to pick. If the fifth term is 2.975, we think it is moving towards 3 and not towards 1. So this is the limit. The limit is 3. So the technique here is to replace this and this with x and then solve. This will give us the limit. Although you may need to make a choice. The way you choose is by looking at the first 5 terms. Please make sure you write this one down carefully. I'm sure it's new for most people.
The 4 minus 3 over x, is that the fixed equation, or just the...
It's just for this one, yeah. So each problem gets its own equation to solve. Focus. Up here. Are you writing this down?
T1 is given, right?
Yes. The things that are given are the formula and the first term. Okay, do you have that now? I'll send the link for this video as well, okay? So if you didn't get it all, you can get it from the video if you watch it again. But I'll give you 1 more minute and then I need to go on to the next example. Okay, I need to go on to the next one. So this type of sequence here, you see this one here? This one is not recursive. You just put the n for whatever number you want. So for example, please calculate the first term. Put n as 1 and tell me what you get. So the first term. Everybody please, give me the first term here. Put n as 1. What is it? It's 9, is it? Yep. Okay, now give me the 10th term.
It's negative 9.
Is it minus 9 for the first one?
No, it will be,
But- 1.539. Okay, give me the 100 and then the 1000th term. Which one? 1.2765 and then the 1000th term? .2526. So does this sequence look like it's convergent or divergent? Convergent, we think. It's not going to infinity, but what do you think the limit is?
1.
Maybe it's 1. We're not sure exactly here. It's not clear where it's going, right? So if we want to know what the limit is, we need to put n as a very large number. And that doesn't really work here, because if I put n as infinity, I get this, which makes no sense. So we need a trick to calculate the limit here. So here's the trick for this. What you do is you take this and divide the top by n squared and divide the bottom by n squared. So now you get this formula. 5n squared divided by n squared is 5. 8n divided by n squared? 8 over n, good. And 5 divided by n squared is 5 over n squared. Likewise, here I get minus 4 plus 2 over n. Now, if n is really, really big, if n was infinity, for example, or a very, very large number, what is 8 over a very large number? It's 0. You know, think about it. 8 divided by a million is nearly 0. So that's gone. And what about 5 over a very large number? Squared. It's also 0. And what about 2 over infinity? It's also 0. So what are you left with? 1.25. So 1.25 is exactly the limit here. But that wasn't so clear, because you thought maybe it's moving to 1. You're not sure. In fact, no, it's only going to 1.25 and then it stops. So 1.25 is the limit here. And this is the trick here. We divide the top and bottom by n squared. Makes it simpler.
This is all the equation.
Yeah, the reason I choose n squared is, in fact, you choose whatever the biggest power is, in which in this case is n squared. But it could have been n cubed or something. Okay, I just have one more example to do. So while I'm doing the last example, can you just pass that around and get people to tick in if they're here? You can just put your tick on the left beside your name. Which group are you in? Yeah. Okay, do you have that written down? Yep, okay.
I'm just, sorry.
I'll give you about 30 seconds. There's an attendance being passed around. Just to put a tick beside your name. And please don't try to tick somebody who's not here, because I know how to count. I can just count how many people are here and how many ticks there are. Okay? See, I'm smart like that. So don't try and do anything for your friends. What? Yeah, and I know to -2 as well. Okay, last example now. Look up, last example. So some decimals like this, oh come on, turn that off. Some decimals like this, you know you can write it as a fraction, like this one here. Sometimes it's not so clear. For example, if I had something like this, 0.1, no, let's make something, yeah, 1, 2, 1, 2, 1, 2, 1, 2, like this. I can write this as a fraction, but the question is, what fraction?
1, 2 over 100.
Nope, good try though. That's not it. Okay, so let's see how to do this. So here's our example. So what you do is you split it into smaller numbers. 0.12 plus 0.0012 plus 0.000012, etc. No talking please when I'm talking. 1, 2, that's the first one. The second one, there it is there. The next one, there it is there. So I've separated into different parts. Now each part I can make as a fraction. So this first part is 12 over 100. This second part is 12 over 10,000. And then this one here is 12 over 1,000,000, etc. Now if you look at this, this is actually geometric, because each term I get by multiplying the last term by 1 over 100. Very good. Yeah. So this has or equals 1 over 100. And what's the A here?
12 over 100.
12 over 100. And the N? Infinity. So you can use the formula I showed you at the start of the class to calculate this sum. It is equal to A over 1 minus or, which equals A over 99 over 100, which equals 12 over 99. 3 goes into 12 4 times and goes into that 33 times. Yeah, no, don't believe me, definitely don't. Type in 4 divided by 33 and see what you get. Type it in. Please type in 4 over 33. Repeating. Yep. So this is equal to 4 over 33. It would have taken you a long time to guess that fraction. Yep. It would have taken you a long time. Yes. Now, for the final exam, I should also tell you that question 1 and question 2 on these pages are very popular. Question 3 I've actually not seen on the final exam, and question 4 I've only seen once. So for this lesson it's really important that you try question 1 and 2. Now, listen, as the engineers will tell you, I give you homework and I'll have you on Thursday. So I'll check the homework on Thursday. So what I want you to do from this page, if you can circle these questions please. In number 1...
Even for us or...
I'm finished, yes?
I'm done.
Thank you. Question 1, I want you to do IJKL, the last 4. In question 2, the same IJKL. And question 3, IJKL. And 4, KLM. This is for everybody, because I'll have everybody on Thursday. Except my engineers, because they're awesome. They don't need to do it. Wait, you believe me? Yeah, they're awesome. Right, okay, so I'll check these on Thursday, okay? I will try and get Lorraine to email you those video links. Yeah? Alright.